Hey there, welcome everyone. I'm Mark Brown, and I've got with us this month Lenni Lobel. Hi, Lenny. How are you?
I am great, Mark. Thanks. How are you?
I'm doing pretty good. Just enjoying my holiday. It's a holiday here in the U.S. Uh,
Apparently.
President's Day. Yeah, you know what? I never know what day is what, so I regularly will schedule meetings on what turn out to be holidays, thinking, "Hey, wow, that guy's calendar is wide open. I'm just gonna schedule a meeting with them." And then I come to realize, like a day or two before, like, "Oh, that's a holiday, idiot." So I end up having to reschedule. Great to have you this month. You're going to talk to us about how to do querying with our SQL API.
Sure
Uh,
am.
Sounds good. All right. Well, welcome everyone. Great to have you with us again this month. This is our Azure Cosmos DB Global User Group meetup, and I'm Mark Brown, one of your hosts, and I've got with me Lenni Lobel. And if you would like, oh, I got to turn this on. Hold on. We've got all right. I've got my drawing tool on there. So if you make a comment, ask questions, you get entered into our drawing where I will send you one of these awesome Cosmos DB stickers you can use to adorn your laptop or whatever you want. And then I will send you one of these even more awesome Azure Cosmos DB neoprene coasters that you can put your drink on. Um, and so feel free to enter our drawing, and then I will send you a sticker and a coaster. So with that, Lenny, it's all yours, my friend.
Fantastic, Mark. Thank you and welcome, everyone. It's really a great pleasure, as always, to be here presenting with you guys and talking about Cosmos. And this session is all about querying with SQL. Yeah, that's right. This is a NoSQL database where we focus on SQL as the primary language to query against your document database. And if you've been to any of my past sessions, you know I sometimes get a little slide heavy. So you'll be happy to know I have only 2 slides, and then we jump right into the demos. So what we're talking about with Rich Query with SQL is this dialect of SQL, this variant of the structured query language which we'll call Cosmos DB SQL. It's a special version of SQL designed specifically for querying JSON documents and the hierarchical nature of JSON documents. And although it looks familiar on the face of it, you are dealing not with tables and rows, but you're dealing with containers and documents. And you're not dealing with SQL data types. You're dealing with JSON data types, which of course there are far fewer JSON data types than there are SQL data types. So yeah, familiar keywords. You know, you'll see select, from, and where. You know, and even join, and you'll say, "Oh, this looks like this looks. I know this." And then you'll realize when you look a little closer that it's actually quite different because we're working with JSON. It's a very different world. And one of the things that this query language lets you do is descend into any subsection of a document, like navigate your way through a path to any level of the document or any array element within the document as you need to. And in the case of arrays, you can iterate those arrays and as well as perform what's called an intra-document join. So those of us know about Cosmos DB know that we don't get the joins between two documents the way we get them between two rows in the relational database because of the distributed and horizontally scalable and non-relational nature of Cosmos DB. But this is a different type of join, this intra-document join, as we'll look at in the demos. And you can return, you know, there's no schema, right? There's no defined schema on these things. So you can return the documents exactly as they are stored in the database, or you can project a custom shape for the query results coming out of your query, right? Here's just a very quick example. At first blush, it looks like ordinary SQL, but when you take a little bit of a closer look, you can see that it's not here. We have this dotted notation, for example. to drill our way down. And this join, again, of course, does not work the way you would expect it to if you're coming from the relational world. So that's kind of the premise for this session, for this presentation. We're going to look at, I won't say all of them, but most of them, most of the available operators and functions. So the common operators, of course, no query language would get off the ground without your basic math, bitwise logical comparison, operations, basic string concatenation, ternary coalesce. You obviously need those operators. But then we've got a host of these other functions, the math functions, type checking functions, which are really come in handy when you're dealing with an unknown schema, and you can test for things being defined or not defined, and if they are defined, whether they're what type they are, a Boolean, an array, an object, or a string, a number, and so on. A boatload of string functions, obviously, to do all the things you need to do with strings that you find in any language. We'll see demos of that. A couple of date times to get the UTC, either as a formatted string or as an epoch value. Array functions to if you bend and twist arrays any way that you might need to. Familiar looking aggregate functions. And as well, we're going to end off by actually looking at some spatial queries that use these spatial functions. And that's it. Those are all the slides I have. I'm going to jump right in now to the Azure portal. And here I am on my CosmosDB account for my Pluralsight course, where I have some sample data for these queries. And what I'm going to do is I'm going to kick off by going to the Data Explorer, right? And we've all been there. So one thing you might not be familiar with is this full screen view, which can be very handy, which I'll go and use now. It gives you these links that expire, so you can share them. There's read and write, and there's read-only versions. They will expire for obvious security reasons, but what they let you do is open up the Data Explorer into like a full screen view without all the extra Chrome of the Azure portal. So this is like the Data Explorer completely filling your browser, and then I'll hit F11, and let me just make sure I'm up at 150%. It looks like I am. So I'll hit F11. I'm going full screen. Hopefully everyone can see that pretty clearly, that I've got two databases here. I've got AdventureWorks and Families. And when I expand these databases, you get to see the containers that I have inside of them. And for these demos, I'm going to run a bunch of queries against the Families container and a bunch of queries against the the stores container. So this is actually AdventureWorks migrated, and this stores container has been migrated over from AdventureWorks. There are 701 stores there. I've got only 3 families here. And I'm going to expand them so you can see what they look like. You can see what these documents look like that we're going to be querying over. In the stores container, again, these came from AdventureWorks, and it's just, basic information with a name and address and a postal code. And the postal code happens to be our partition key, this one right here. We've got some foreign companies as well, as you can see. And over in the families container, when I go over to that container, you can see I've got only 3 documents. And in these documents, I've got typical information you would find about like a family, who the parents are, who the children are. And I've got the Anderson family here in Washington. If I scroll down a little bit, you'll see that I've got a property here called geo. This is a geo JSON formatted coordinate, a point. You have points, lines, and polystrings, your basic spatial types. So I've got, they'll serve for our spatial queries later on. Here in Seattle, and the Smith family and the Wakefields are in New York, one in Queens, and the other literally right in Manhattan, right? That's where they're located. And there are arrays of parents, and there are arrays of children, and children's have nested arrays of pets. And we can also see that we have an inconsistent schema here. So if I look at the Anderson family's children array, the child's name's property is first name. But if I look at some of the other documents, the other 2, it's given name. So we have this varying schema. So it's not uncommon when you don't have an enforced schema in the database, the schemas evolve, and then you're faced with the dilemma of like, well, now how do I project the consistent view of this data? So we're going to see how we get all this accomplished with SQL queries. All right, so let's shut down these items and let's have a look at our first SQL query while saying new SQL query. And it starts off looking very innocent and very, approachable. It looks very basic, select star from C, but again, it does not work necessarily the way you think. Both select star and the from clause work very differently than regular SQL, if you will. And hope folks on the Cosmos team don't get mad at me for calling that regular SQL. And it's just easier to say that than relational, SQL Server or T-SQL. But anyway, let's go ahead and execute it before we, break that down. And of course, this is saying return all the documents from the container because there's no where clause. And I'm saying select star. And of course, there are the 3 documents. So, all right, so let's break it down. Now, how did these results get returned? First of all, if I collapse it down, we can see our results always come back in an array. Even if you're returning just one document or one item or one value, which is not even a document, it's like a scalar value, then it'll always be wrapped in these square brackets for the JSON array. And then you get one item or element in that array for each result coming out of the query, right? Now, if I expand them now, you can see that they're being returned exactly as they are shaped. So now if I talk about the select star, you know that select star in the relational world is generally discouraged. It's usually considered a bad thing, and you should be explicitly listing out the columns that you want, even if it's all of them, right? Select star is just generally considered bad practice. And here in this world, though, it's really the only way that you're going to get documents out of the database exactly the way they're shaped. And select star is not at all discouraged in this dialect of SQL, right? If you need to get documents the way they're shaped without projecting them or transforming them in any way, then you have to use select star, right? So if you want the raw documents, you say select star. But if you replace that star with something else, which we'll see soon, you are defining a consistent shape for the results coming out of this query, that every document is guaranteed to fit this shape. And then you could, in that case, for example, resolve some of those schema differences between given name and first name in those children array and things of that nature. So that's select star. And the from clause, so a Cosmos SQL query always runs within the context of the container that you're connected to. Right, so I'm connected to the family's container, right? The actual container that you're running this query on is not inside the query. It's always outside the query, like where you attach this query to, and I'm attached to the family's container. So you'll see, in fact, that C is very often used for container. And what I'm going to do now is I'm going to jump on over to our first set of queries. I mean, it can make you wonder why you even need a from clause, right? Because this is not the name of the container, so why do you even need it? And the answer is, in fact, that you don't need it. Although if you don't include it, then you're not querying the container. You're just running what's called a scalar expression query. You're just calculating a value and getting a single result. And while you generally don't run those types of queries, they're a very handy way to get started with learning about all of the capabilities of the query language. So that's what I'm going to do. That's what I'm going to start off with. I'm going to select this family's container again and choose open query. And you can store queries either in blob storage or locally. And I've got these locally, so I'll open these from disk. I've got a bunch here. We're going to go through all of them. Let's start with these so-called scalar expression queries, just to get us acquainted, right? So let's start with the first one. Select hello. And these results may look a little odd. Let me maybe make it even a little bigger here. These results may look a little odd, but let's break it down. Well, first of all, I already explained the results are always coming back in an array, so we get those square brackets. This is a scalar expression query. There's no from clause, and therefore we're only getting back one item, which is one document, and that's this document here. We asked for a single property, and we supplied a value, but we didn't supply a property name. So we get a JSON document where the property name is auto-generated, which is usually not what you want. You usually don't want those ugly property names. So that's where the as keyword comes in. And when you append as word, you're defining a name for the query. I'm sorry, a name for the property, and that's kind of much more what we would want, the property name and property value. And then again, you can return not just full-blown objects, but you can return scalar values. And if I'm only returning a single value, like a single string hello, I can produce a linear result set by supplying the word value. And now I'm just getting an array with the one value hello in it, right? Now let's bump this up to 2 values. I can't use the keyword value because it's more than one value. Only with one value can you supply that keyword. So we get back our object where we kind of specify 2 property values, but without property names. So we get the auto-generated names. So again, we'll use the as keyword to alias those to the proper names that we would want in our JSON document returned, right? So we're controlling the property names with as, if you will. All right. Now, they got very clever with the way they implemented the query language in allowing you to actually embed JSON directly into the select clause, like JSON syntax, brackets, if you will. In this case, an array of strings, using as to define a property called words, the value of which is this JSON array. So it's an object. I think it's a little too big now. So it is an object. As words gives it the property name words, and the value is the embedded array. And you can embed curly braces just the same to project a custom object with 2 properties, right? So that there's my object. My object has a property called words, and that is itself a JSON object with these 2 properties in it. I don't need to use the word as here because I'm just embedding JSON structure into the select clause. It's kind of very much nicer alternative to using as, and kind of you get to see what it's going to look like, right, in the query. And of course, there's nothing stopping you from combining square brackets and curly braces and getting really fancy here. And I've got a property called all words using as to just define the property name, but the property value is basically shaped out right here, with 2 property, words 1 and words 2, each of which is a string array. It's really easy to just kind of shape it the way you need or to want to. Okay, so let's bring that down again. Let's move on to I think that's the end of that script. So we'll open the next one. And these scalar expressions are also a very handy way to get familiar with all the operators and functions. So here's some basic math functions. And you can see from the result that because our first expression has only integers, the result is an integer. And because our second expression had a decimal, the result is a decimal. And all of your basic arithmetic functions, as you would expect, right? Logical. These are all really simple, true and false, because I'm using parentheses to override, this always being true. And so the second expression is false. We got these comparison ternary and ternary coalesce. So let's look at the ternary, just like you would, like an immediate if, if 3 parts, the expression to evaluate the result if it's true, the result if it's false. And coalesce. Coalesce really comes in handy. So it really comes in handy when you're not sure about the schema of the document that you're returning. Now, I'm going to keep talking about ways that you can cope with varying schema and when you're uncertain about what type of document you're looking at, since there's no enforced schema. But the reality is that you should impose some discipline on yourselves and on your developers doing your data modeling. You should always have a type property. And I would even argue you should always have a version property. So a type property makes it, unambiguously clear that you're dealing with an order document versus a customer document, rather than making brittle assumptions about the shape of if the document is shaped this way, then it must be a customer document. Yeah. So this is the kind of things that, but assuming that you are in that situation where, I don't know what type of property, I don't know whether I'm going to find the first property or the second property or the third. I mean, you're going to see an example of this against a container in a moment where, a lot more obvious, but it essentially just returns the first value that's not undefined, where properties that don't exist in a document are considered undefined. So it just returns the first undefined one, right? if that wasn't clear, you'll see it. It'll be much more clear when we run it against real data. So here's just some basic string concatenation, right? I'm using the double pipe symbol to combine 3 strings, okay, into one property called string concat. Math functions, all of your basic rounding functions, round, ceiling, floor, absolute value, sine, cosine, tangent, natural logarithm, and pi are all supported. Each of these are rounding or rounding differently, but if you don't want to spend too much time looking at these numbers, but here are the results. Okay. Pi looks right. Okay, 3.14. All right, type checking. And this again comes into those cases where you're making arguably brittle assumptions about the shape of a document. Think, assumptions that could break all too easily. So again, try to have that type property and that version property. But if you don't know if something is an array, or if it's a Boolean, or if it's null, or if it's an object, or even if it's defined, that's what this set of functions is for. Right, so 6 is certainly not an array, but if you wrap the brackets around it, well, that is an array. And 6 is not a Boolean, but false is, right? And you can test for null, and you can test. Here's object, that's a string, so that's not an object. Here, I'm passing in an actual object, so it is an object, right? So you need those type checking functions in this loosely typed world or non-typed world. For string, oh yeah, all the obvious ones. I don't think I have to say much about these. Concatenation starts with, ends with, index, substring, left, right, lower, upper. It's all there. All right. Then you've got all these string to this and string to that functions, which let you basically pass in a string and convert it to any of these things like an array. Like if I have a piece of a string that is an array, I can just pass it in to string to array. I'm generating arrays in every case, including nested arrays, as you can see. All right. Moving on. String to Boolean is just actually literally searches for the string true and false. So it's just string to this and string to that. It's able to convert strings to Booleans, to nulls. It actually searches for the word null to tell you if it's null, which would be just the, all of them, basically. And when wrapping is null around string to null, it tells you that it's truly null, right? String to number. Oh, these are obviously really important, right? String to number, they all work. They all give you, as you can see in the results, numeric results. String to object, just make sure the string is formatted like an object properly, and you will be able to convert it into a true object. Yeah. Object 3. Structure this way, coming out looking this way. And what else? ToString. Got to have that. Got to be able to check for nan. Hey, kind of interesting. This returns itself undefined, and therefore we're not getting stir 8. I actually never noticed that one before. That's a good one. All right, cute, cool. All right, so wrapping up almost with this script, date and time. There's just these two. We'll give you the UTC date and time formatted as a string or as an epoch value, which is really just the number of seconds elapsed since, I believe it's January 1st, 1970. It's the same format as you have in the _TS property in every document, the timestamp property. Finally, the last one in this script, all these array functions, you can concatenate arrays. You can test if an element exists in an array, get its length, and of course, extract just a subset, like starting from index 1, return, give me 2 items from the array, and give me just that slice. Okay. I could pause for questions if there are any, or we could just jump ahead to actual container queries.
Yeah, I don't see any questions yet,
Okay.
but yeah, let's just keep going. If
All right.
I see some questions, I'll
Okay.
pop back in.
Great. So again, connected to the family's container, let's Open up a new query from disk, which would be our next one, number 3. So again, once you attach a from clause, then it's no longer a scalar expression query. It actually queries from the container. And here is the same query we ran before to get the 3 family documents. Select star from C. C is just means an alias for stands for container, an alias for the container that we are actually connected to, families in this case. Now, what if I don't want the full documents? I just need the city and the state. Well, then just spell them out, right? Now I'm just going to get my result. I'm still getting 3 documents. I'm still getting 3 results because I'm getting 1 result per document, but I've shaped it a certain way, right? Yeah, every document has city and state, even though it's nested beneath the location property, because I didn't supply an as, it inferred the property name from the leaf level of the expression, if you will. Okay, so just those 2 properties as 2 top level properties of each document returned from the query. All right. Now, again, there's nothing stopping you from using the so first of all, let me just point out that these prefixes here for the alias, whatever alias you choose, they're required. Like, you can't omit them like you can in regular SQL. So you'll get an error if you leave that out. So again, there's nothing stopping you from using aliasing the families, continuous families, if that's what looks better to you, because you want your query to be more semantically expressive. You know, if that's your intent, you might want to say from families, and that works just the same. But again, because the prefix is required, then it adds up to a lot of extra typing that you might want to avoid. So again, this may sound weird, but you can alias the alias if you want. If you want the best of both worlds, where I want it to be very clear from someone reading this query that I'm querying families, the families container, or at least family type documents, if you will. But and so I spell it out there, but I can alias that alias, if you will, as a shorthand F to indicate family fields, and that works just fine.
I got a couple of questions.
All right, let's have them.
I think one of them might tee up the next section for you, but let's start with this one. How would you handle a free-form Word document?
I wouldn't, because that's a free-form Word document. When you say Word document, to me, I'm thinking Open XML, and that's XML, and it's not this world.
Right.
Right.
Yeah. I
I'm
mean, a Word
thinking C#
document
and
it's just a bunch of
yeah.
characters. You've got to have properties in there and values, right?
Well, again, you know, a Word document is, if you just tack a .zip extension to any Word document, you'll get a zip file, and you'll find the whole contents of that Word document is just XML inside that zip file. And to query free-form Word documents, you're querying that open XML, and that's another world.
That's XML. We're not XML. We're JSON.
We are not XML. We are JSON.
Okay. Another question, and I think you're going to talk about this next. Can we run subqueries?
You know, I'm not going to talk about it next, but the answer is, can you run subqueries? Generally not. I mean, you have something called correlated subqueries, right?
Right.
But I'm not covering that. But I'm not covering that, and it's essentially kind of a way to improve the performance of what would otherwise be a single query. They're not subqueries the way you're thinking of them, like a CTE or something, where you can like form one query and then query from that subquery and then query from that subquery.
Yeah, they're not the same. That's right.
No.
I mean, we have subqueries. Those are
no. Correlated subqueries in Cosmos SQL are just kind of a way to improve the performance of what would otherwise require iterative processing behind the scenes to get the same results.
Okay, that's it for questions.
Okay, great, cool. All right, moving along. Now, what if I don't need the entire document, but just a subset? What if I just want the children? Well, I can say from C.children, and when I do that, I'm still getting back 3 documents, because the 3 documents in the results, because it's 1 document in the result per document in the container. But you can see that the value of each document is itself an array. I'm getting 3 arrays because I asked for C.children, and children is an array, and I'm getting an array of 3 arrays because there's 3 documents, although the first array has only 1 document in it because it's an only child. I think it's because I magnified too much. Okay, right. And the second one has 2 children, right? As you can see, and the third one has also 2 children. So it's really 5 children spread across 3 documents, right? But I just need the subset. Now, that will improve the performance of a query where you don't need anything outside that subset. But at the same time, you can't query by any property outside that subset either if you do that, because you're reducing the scope of the query and you're improving performance in that manner, thereby excluding access to anything outside or at the parent level of that subset. So this will fail. Okay, and but what if that's what you need to do? What if you need to get just the children from New York? Like, how do you do that? Because the New York property is up and outside of the children subset. Well, then you go back to saying from C, which brings the entire document back into scope, which allows you to query into the location property, which is outside the children, and then just return the children property, right? So it's a compromise where you're still returning a smaller document than a full document. So latency and bandwidth will overall be reduced, but from the query performance perspective, it does have to process the entire document in order to satisfy the where clause. But here you can see that it works. I'm only getting 2 documents. This time the results are not arrays. Is a subtle difference than this variant because I am getting the children property. So why is it not? Oh, there we go. Okay, I'm only getting the 2 children from New York, but they're returned as objects with one property called children because that's the only property I selected, and that is the array of children. Could be any number of children, but there's only 2 families, right? So what if that's not what I want? What if I want 1 document per child, right? That's where in comes in, and in essentially lets you break or flatten, if you will, a parent document onto multiple children documents based on the array that you specify after in. So I'm still aliasing the container as C, but drilling into the children property and aliasing that as CH. Okay. And now I'm getting 5 documents. I've turned 3. I only have 3 documents in my container, and I just pulled back 5 documents in my results set. How did that happen? That's what in does. It breaks on children, right? So now I'm getting 1 document per child, and I'm getting the full child content. There are 5 children across 3 families, but I'm getting 5 documents in my results set. Okay. Now, as we saw before, okay, well, actually, let's do something fancy first. Let's do something fancy with each one. We'll keep the from clause, but we'll replace the star, right? We'll try to resolve some of these schema differences where we know that some children, now once we break on children and we alias that as CH, I can use CH here to access each child document, right? And I can test for given name because I know some documents have given name, and I can use coalesce because if that's undefined, then I can check first name. And if there were other possibilities, I could keep tacking these on. But in the end, I'm going to get back a property called child name in every document coming out of this query. I mean, I'm defining a schema. I can even type it on my client side. And we should serialize right in, right? I want the grade. I want the number of pets. But some documents don't have a pets property at all. I didn't point that out earlier, but some properties have them, some properties don't. Some documents have them, and some documents don't have this pets property. And what I want is I want to make sure that I get a number of pets property no matter what, even if it's 0. And that's where this coalesce comes in, because again, if any property value comes back as truly undefined, we won't even see. It won't even get serialized. It won't even be part of our document. And let's see the pets array as well. And now I'm still going to get back 5 documents because I'm using in to break on children. But every document is shaped the same. Child name. Number of pets is 0, even though there is no, Michelle doesn't have a pets property. Let's see, just to prove it, let me take out the coalesce. See, Michelle, she has number of pets 0. But she doesn't actually have a pets property. If I take out the coalesce, Michelle no longer has a pets property, a number of pets property. So that's, coalesce comes in really handy for those types of situations. Now, as we saw earlier, when you say when you don't specify the full document, but you specify only a subset, then you can't query outside the subset. So now it becomes a problem. What if I want each child document to actually have some of the parent information in it as well? That won't work here, as we saw earlier, because I'm limiting the scope of visibility to just the children subset. So I can't include like the parent name. And that's where join comes in, and that's where the intra-document join comes in. Okay, so I'm going to do a similar kind of query, but I'm going to use join. Let's just focus on the from clause first. Oh, so sorry. If you focus on the from clause first, okay, from C, it's aliasing the container as C, and I've got the full document in scope. And that document I know is a family document, so I'll alias that as F, so that throughout my query I can say F dot this and F dot that when I want to pull something from the family level. And then join this in, breaks it apart like we saw before, aliasing it as CH, but because of the join and we have the parent, we do have access. This is this select portion of the query. This is the same as we had before, but now we can include family information. And so that's very unlike a join in the relational database world. But like a join in the relational database world, for each child that gets duplicated, for each child belonging to the same parent, that parent information will get duplicated for each child, right? So let's go have a look here. Remember, we've got 3 family documents in the container, and we're getting 5 results out of this query. But you can see that the family information, okay, only 1 child from the Anderson family, 2 children from the Smith family. So these first 3 properties are duplicated just like a regular inner join in relational SQL, right? But it came from the same document. We're not joining multiple documents together. The parent information is simply at the parent level of the child array being iterated.
You got a question from
Can you hold that question for one moment?
Sure.
Yeah, because the last part of this is, given the fact, again, that each child itself has a pets array, and some have no pets. Some this one has 3 pets, right? And what you can do is you can keep piling on these joins, as I'm doing here in this next one. I'm saying this is the same query as before, right? Except I'm joining now on each children object has a pets property. I'm aliasing that as P. So I can get the family ID all the way from the top root of this hierarchy. I can get the child's given name. And if a child has more than 1 pet, then that child information will be duplicated for each pet. Again, just like if you did piled on the joins in regular SQL. And so now I'm getting 1 document per pet. So I'm turning 3 documents now into 6. And you can see some of these, like Jesse. Jesse's got 3 pets.
Yeah, it's a lot of poop to clean up, isn't it?
Right. It is. But now, if I'm really just interested in, so you see it basically how easily I can get 1 document per pet. You can get 1 document per any level of any array across all your documents. And then if you're really just interested in detailed information about that level, like I really just want the pet name. This is the same query with the double joins, but I'm just getting the pet name. And when you run this query, now I'm getting a name of a list of all the pet names. It's just pet names. Now, of course, this should look instinctively wrong to you. It's needlessly verbose. What do we do when you have a situation like this? It's always best to use value. So the same query with the value keyword gives us a nice, same joins, but now with value, I'm getting a nice, lean string array of pet names. If that's what I need, an array of strings with all the pet names across all the children, across all the families, across the entire container, this gives it to me in the leanest fashion. Okay, question.
Couple of questions for you now. Go scroll up to, I guess, line 62 in your query there. Would I be able to generate an equivalent query that uses array length using LINQ?
Okay, so LINQ, there's a LINQ provider, language integrated query.
Yeah.
If LINQ is, I'm not the biggest fan, but I mean, I'm not the biggest fan of any link provider that translates C# expression trees into the DSL, the domain specific language. Although there is a link provider, and I have a demo of it in my Pluralsight course, and if it works properly and extensively, you should be able to say dot length in C# and use the link provider to have that get translated here, and that should work. But that is the topic for like a .NET SDK session, where you can query either by constructing strings of these select statements the way I'm showing here. Like all these select statements in the .NET SDK, you just shove them into strings, right? You can parameterize them, but basically you shove them into strings and then you just run them like that. Or you can use a link, which is what this question is about.
Yeah.
And it's it should translate the full supported set of functions that are in the SQL language should be supported on the C# side as well.
All right. Another question. Are these joins going to result in cross-partition queries? Okay.
Are these joins going to? No, never.
No, because I mean,
it wasn't within the document. The query itself is either a cross-partition query or a single partition.
The joins themselves are within the document, which
right. Well, yeah. I mean, any query without a where clause is obviously a cross-partition query.
Sure.
Right. So, but that's arbitrary here. I could have added a where clause here to narrow it to a single partition, and no matter how many joins you have, it would remain a single partition query.
That's right.
Right.
That's right. These are joins within a document, which of course are always
intra-document joins.
That's correct. Okay. More questions here. One more. What are your thoughts on the distinction between undefined and null?
Oh, don't get me started. My day job, I'm doing a lot of TypeScript, so we all know about that. Yeah, it's well, look, it's nice that you can make that distinction, right? Right. Defined is different than null, right? So undefined means there's no such property. It's probably not even the right type of document. Whereas null means, okay, the property exists, no value's ever been supplied for it, and you want that distinction. So that's the guidance.
This is the beauty of JSON, is that in a tabular world, undefined doesn't make sense. Right? Because your schema is enforced at the
your schema is always defined.
Right.
Right. So when I said before, like, don't get me started, like rolling my eyes. The truth is, it is nice to have that distinction between undefined and null. You do need that distinction. The problem that I have is in TypeScript with truthiness, where you have it could be a boolean where null, undefined, and false are kind of all equate, or even worse. I mean, yeah, it gets really. If you do TypeScript, you know that you often get tripped up because something's undefined rather than null, and you have to test for both, or it's just it can get a little ugly. But it's good to have the distinction. You need the distinction.
Yeah. One more question for you. This is good. They just kind of pile on. What would it look like if pets were a separate document in the same container and not embedded? Yeah.
No, separate queries. What you do then is you have separate documents. You cannot get them in a single query. If the pet documents are verbose, and that's why they're separate documents, right? They have a lot of properties, and the children are also verbose. So they have a lot of properties, and for that, among other reasons, you have them as separate documents. You want to denormalize the most commonly accessed pet properties. Like if there are a lot of pet properties, but there's like 3 or 4 that are most frequently queried along with children, and keep copies of those values in the children document. Use the change feed to keep that family document in sync, that child document in sync with its pets.
You would never model the data like this. Like you're not going to get an unbounded array of pets unless your mom and dad can't say no.
No, I don't think that the question was taking pets literally. I mean, yeah, with pets, you wouldn't, right? Because it's not unbounded. You're only separating them into separate documents because it's unbounded, right?
I see. I thought it was a document per pet, but that doesn't. But
no.
Putting all the pets into a single document doesn't make sense either from a model.
Yeah. I mean, it depends, right?
I guess it
if,
depends. I mean, yeah, if you're doing a lot of like a massive, if you have really high asymmetry with updates to pets versus like the family and the children, then I suppose
that's another reason to
but
keep them separate. But then again, if you had many pet properties, but you most frequently access the pet name, you would want a copy of the pet name property in the child that owns. Child is a bad name because child is the parent of the pet, right? But I'm saying the child's document that is the owner of those pets, right? But those pets are external because of asymmetry, as you said, or because it's unbounded. You would still want to keep like the pet name, so that because if that's
so
your most common
he's
query.
clarifying. He's like not just pets, but if you could join different documents in a container, and the answer is no.
The answer is no. It's all these,
It's all within a document. You can do joins.
Mm-hmm.
So okay, more queries or questions. I guess they kind of like queries.
Maybe we can take a pause for some at some point and pick up after.
Sure. You want to keep going, and then
I mean, how many more questions do you have queued up there?
One person has 2 questions.
There are two more questions?
Yes.
Okay, let's hear them.
Okay. Join queries won't be using the indexes and searching for documents across all replicas. What?
Again?
Join queries won't be using indexes and searching for documents.
Okay, this is a similar answer.
So I think people are confused. Like you don't join documents; you join pieces inside of documents.
Yeah.
Right. And yes, they all use indexes. It's not. I mean, it has nothing to do. The join has nothing to do with indexing.
Right.
So okay, one more. Same guy, person. Sorry, I don't know if it's a guy. Join queries won't be using indexes and searching for documents across all replicas.
You just said that.
Partition queries. Yeah. Okay. I think it's the same. Oh, it is the same.
Okay.
Question.
All right.
Okay.
So
back to you.
All right. So I don't even remember which one we were up to, but let's just.
You finished all your joins.
Yeah. All right. So I'm going to jump over to the my store container.
Okay.
I'm sorry, the stores container.
With more questions.
Yeah. This is. Yeah. When there's more questions, we'll get to them. We're going to. Now run some queries against the store container. Remember, this is the container with the 701 documents that we imported from AdventureWorks. I'll open a query from disk. So look, same exact query we ran before on the families container, just to drive the point, right? The container that you're running the query on is defined from outside the query. Right, so this is the same query I ran in the families container, but now I'm getting stores. And there's no where clause, so I'm returning all the source from the entire container. And of course, in typical fashion, in standard Cosmos fashion, you get it back in chunks, you get it back in pages. You don't get it back all in one stream. So in the case of the portal, each time I click on this link, I get the next 100 and the next 100 results for a total of 701. Right? I don't need the full document, just to a little rehearsal here, a little review rather. I don't need every single property. I just need the ID and the name. So I don't use select star. I just spell out my properties. If I just need the name, then I just specify the name. I look at that and I say, it's probably better to add value. Now I get an array of store names. Let's look at string concatenation. I want to take advantage of this value. I want to keep this as a lean array as opposed to being documents. They should just be strings, but I need to concatenate. I need multiple values. Well, if I concatenate them all together, it still becomes a single value, and so I can still use the value keyword. And now I've got the name concatenated with a comma and a space and the country as a string array, right? Concatenated from 3 sections. All right, custom projections. Remember when we were looking at scalar expression queries, how I was showing you can embed syntax, you can embed curly braces and square braces. Well, what if you have a requirement to project a certain shape that is in no way resembles the way the documents are actually stored in the database. Like you just have this need to produce one document for every store, but it needs to be shaped this way. You need a country property with the country region name, and then you need a store info property that has to be an object shape just like this, with a store name, and and you extract from the various parts of the underlying document, but you're constructing a very custom shape here. City state zip as an array that includes, like I said, it doesn't include the zip, does it? But the city and the province name as array elements, and then this metadata object with an internal ID and a timestamp, which comes from TS. Basically, very custom shape. And I'm getting them. And this, of course, is the custom shape that I composed, if you will, in my query. There's a country property, there's a store info property shaped exactly the way we needed it to be. But these don't look anything like the documents that are in the database, do they? Right? So you can project any kind of custom shape you need to. Let's look at some range queries. If you just need the stores from A through K, you can use this query here. See, it's not sorted. We'll look at that in a moment. If you're testing both upper and lower bounds, you can do the same thing with between. And of course, probably going to need the balance of names between L and Z. And like I said, it's not sorted. So let's, to get a sorted list by name, order by. It's down just a little bit. And you see it's in alphabetical order. And of course, as you might expect, you can get the results descending. But what this query illustrates is that everything here is case sensitive. So here you've got the lowercase e sorting after the uppercase y when you're going descending. Now, this is just the way it is. So if this is an issue for you, the resolution here is to actually maintain two separate copies of this property. One that's used for display, which would be in mixed case. One that's used for sorting, which would be, in a case insensitive, all lowercase against all lowercase, if you will, if that's what you need to do. You can use top in a way that makes sense, that you're thinking, just the top 10, for example, and you can get paged results as well. So I can say, if I say offset 0, that means the first page, and then limit 10. So that's going to be the same result. A bicycle association through activity center. It's going to be the same as top 10, but then I can say offset 10 to get page 2, if you will. After activity center comes advanced bike components and so on, then alphabetically getting one page at a time. We can also, again, different ways of projecting different shapes out of your query, kind of concealing the underlying shape of your documents. Here's a query that is essentially flattening results. It's not just returning a subset of values. It's taking city, which is nested beneath location, which is nested beneath address, right? It's just flattening. It's just making it a top-level property. Remember, this is inferred. The leaf node here, the leaf value here is inferred as the property name. The same with country region, which is nested beneath address. I'm just getting the 4 properties I want in a flat object, because that's what I want. That's what I need. I'm going to get all the city and state names. Okay, now I'm bringing the entire document into scope. If this was a very, very large document, and I only need these 2 properties, it will be more efficient, even though this isn't getting the same exact results here, to run this second version of the query, where I'm saying select star, but I'm limiting the scope of the query to just the location property, where the only 2 properties nested beneath location happen to be city and state province name, as I was spelling out before, right? Right now, we know that so this would be more efficient in those cases if especially the larger the document is and the narrower your need to project is. As far as your need to query, we understand that this is limiting your scope of visibility. You can't query Now, on this second version of the query, which is more efficient, you cannot query on parent level information, right? We know that already. But you ought to be able to filter on data that's within the subset, right? So if I'm limiting the scope of visibility to location, I ought to be able to filter on state province name, which is within location. Surprisingly, and I really, to be honest, don't know the reason why it doesn't let you do this. It makes you, I still don't have an answer. Maybe Mark can come up with an answer on this one, but we have to add an alias. You're forced to add an alias, and then you can filter on that subset. You can keep it nice and performant by narrowing the scope of visibility of the query to just the part that you need. And if you need to further filter within it, you just are required to add this alias. I'm aliasing location as L, and also you'll see that just like regular SQL, I can use in to test not just for Florida, but let's say for Illinois. And that works just fine. I'm getting all the stores that are in Florida and Illinois. All righty. Calculated expressions. If you, I can supply an expression. This is a calculated column, if you will, calculated property. I'm defining a property called is same city state, which is going to be false in most cases, where the city and state is different. However, oh, it's here somewhere. I know it's here somewhere. There, Quebec. It's the same. All right, city and state's the same there. The ternary operator. I need to manufacture a currency property. I'm only filtering for United States and Canada, so I know it's either United States or Canada. So I can say if it's United States, then it's USD. Else, it's safe to say CAD for Canadian currency. And here you can see we've got a mix of USD for United States and CAD for Canadian currency. And you can, it gets ugly, but you can infinitely nest these ternaries. If I'm also pulling in France, now there are 3 possible currencies. So the way this reads is if it's United States, use USD. Else, if it's Canada, use CAD. Else, assume it must be France and use euro. So there's euros in there somewhere. Maybe on page 2. Come on. There. Pretty bikes and toys in France. Euro. Okay. Moving on. That's it for this set of queries. Let's look at some aggregation queries, and then we'll wrap up with spatial queries. So I would estimate another maybe 10 or 15 minutes, depending on questions, of course, to make it run a little longer. But I've got about 10 minutes or 15 minutes more to show. Okay. Let's go on and open up our. So this is kind of an interesting story too. I was telling Mark about this earlier. I'm gonna open up this query from disk. So aggregation queries, some count, min, max, and average. These were, first of all, they were late to come in the first place, and then they came without group by. Now we have group by, even though you need to use the SDK or the Data Explorer. It's not natively supported. There's special sauce in the Data Explorer that will be able to use group by, and if you use the SDK, it takes care of that for you as well. But there was also another interesting discovery that I made literally moments before presenting today. So some of these comments are out of date. So let's say I want to find out how many documents do I have in the container in this zip code. Now this is the partition key. So if it's a single partition query, it works just fine. There are 3 stores in that zip code. This comment is out of date. It used to be that if you wanted to do a cross-partition query, like this thing across the entire United States where I'm partitioned on zip code. So clearly that's a cross partition query. This used to not work, and now you can see it does work. So somewhere within the past year, that was they added that, which is really nice. It used to be the only way I could get that 427 count. There are 427 stores in the United States out of the 701 in the entire container. You used to be forced to use value if you were going cross partition, and what the ramifications of that meant that, well, you know, when you're using value, you can only return a single value. So if you need more than one aggregate, you need some count, min, and max, and it's cross partition, then you have to run 4 separate queries, each one with value. You can't just run one query, or you couldn't run just one query for all the aggregates if you were going cross partition. But that's a nice, you know, applauding that. That's really nice. It's really good.
You're
But
welcome.
it doesn't. Okay, great. But it does mean that some of these demos are a little bit out of date. Let's get. Actually, I threw these in just a moment ago as well because I didn't have any group by examples. So let's take our typical group by example. Run this query. I'm not doing a group by here. I'm just showing that we've got stores, you know, in different states. If I query just for the United States, you have some in New York, you have some in Washington, Oregon, Ohio, right? And what we want is your typical group by query, which is to say, I want a list of states and a total count of stores in each state. Very basic, right? So we can do that. Thankfully, when they added count initially, we didn't have group by, but then it took a little while, but we got group by. And this was also after my discovery that you don't need value. So this wouldn't normally, I would have to put value with this by itself and then run this as a separate query because this is cross partition. But now thankfully that's been fixed. So I can do a group by state, province name. I want the count of stores and I want to see each state. And that's exactly what you get. So it's very, very welcome functionality. Having said that, you know, real heavy duty analytics, that's what Synapse is for. That's what the Azure Synapse link is for. The column store, you know, the analytics store in the container that then replicates over to, that links over to Synapse with near real-time updates of a column store representation of your transactional data. That's where you do your heavy analytics. But if you need to run these aggregation queries, you see here's how you can do it. I've got now some family aggregation queries. And that leaves just a spatial to wrap up the session. All right, so not that we have to use value anymore. It's a cross-partition query, but what are the total number of documents in the container? There's only 3. Not a little underwhelming, but you know, we just want to demo a few things. Like if I break 3 family documents into 5 children documents, and then using in like we learned earlier, then I can use the min function on the grade property of each child to get the child with the lowest grade across all families. And the lowest grade is 1. I could do the same thing with max, exact same thing with max. And I can get the average grade. So it's between 1 and 7, but the average across all children is 4.4. I can run min over array length. So I'm getting 5 documents. I'm getting 3 documents for the 3 families, and each one has a children array. I'm getting the array length, and then I'm using min to find the families that have, you know, what are the fewest number of children? You know, we have families with only 1 child. Which family? What's the maximum number of children in any families? Only 2. But it's the total number. We'll use sum, right? The array length of all the children. There are a total of 5 children. We know that. We've been doing that join on children to get 5 documents from 3. And then if you join on children, if you use in on children to break down the children documents, and you get the pets property of each one, well, we know there are 6 pets across 5 children across 3 families. And so the sum returns 6. Aggregates for New York children. So This was written before. I didn't realize but this was written before they made it possible to do this, even with cross partition. You see, I'm running multiple aggregation queries. That used to be possible only with I'm sorry, multiple aggregation functions. That used to be possible only with single partition queries, such as this one, because I'm partitioned on state and I'm limiting it to New York. So I'm able to get in one query 4175. There's 6 documents, there's 6 pets across the entire container, but in New York, it's down to 5. And yeah, this is just to keep me honest. If you look at the results of this query and you start counting things up, you'll see that they match. For now, you're just going to have to trust me. All right. If I say for all children, right? Oh no, this is again just to do this is just to keep me honest again, just to review these values here. This adds in one more child and one more pet once I go cross partition. And before before they made it possible to do it all in one query, you have to say value. And if I wanted, these different aggregates, I had to run them as separate queries because I had to use the value keyword because it was a cross partition query. But now watch, I'm just gonna leave out the where clause. And now it's working across all partitions. Oh, sorry, wrong one. Aggregates for New York children. Leave out the where clause. This used to not be possible. I used to have to run them as 4 distinct value functions, but yeah, now it's a total of 6 pets, right? And there's 5 children across all of them. And let's just wrap up with some really fun queries, which are spatial queries. So remember at the beginning, I was showing you those family documents. I was showing you that GeoJSON property. That's this property right here. I'm just going to pull out family information, the Anderson family. There's the ID, the city, the country, the county, and the state. Okay, so in Seattle, we have the Anderson family. This is the coordinates in Seattle. This is the Smith family in Forest Hills, Queens, and their coordinates. And these are the Wakefields. They live in Manhattan, and these are their coordinates. Okay. So now what I'm going to do is I'm going to use the st_distance function, which takes 2 GeoJSON values and returns the distance between them. So what I want to know is how far you are away from New York City. So I'm going to take your geo location, which is one GeoJSON property, and compare it against another GeoJSON property of type point, where these are the known coordinates for Midtown Manhattan. So across the country, the Anderson family lives a cool 3.8 million meters away from New York City. The Smith family in Forest Hills, they live just across the East River, about 12,000 meters away from New York City. And the Wakefields, where they live in Ground Zero, right? They're literally 1.1 meter away from Midtown Manhattan. And as you can tell from the way I named this property, the results are returned in meters, and therefore you can easily add this multiplier, if you will, or do a divide by 1,000 in order to get the values in kilometers, which is a little bit more reasonable. Yeah, sure, it makes sense. Across country, you're 3,800 kilometers. If you're across the river, you're 12 kilometers away, and if you're in Ground Zero, you're only 1 meter away, so it's 0.0 whatever. Add in this multiplier, and you'll get the value in miles. So Seattle would be put at 2,400 miles away. Smith family in Queens, 7.5 miles away, and again, the Wakefields are right there. So now what I'm going to do is I'm going to take that st_distance property that's been in the select clause, and I'm going to plug it into the where clause. And this is where it's kind of important to make sure that you have spatial index is defined. I mean, the queries will run without spatial indexes, but they will run a much higher RU charges if you don't have spatial indexes on your documents. Where in the where clause here, I can say, hey, this tells me how many miles you are from New York, like we just saw. Well, you have to be within 8 miles. I only want to get the families that are within 8 miles. I'm filtering now on spatial calculation, and of course, it's just the Smith family in the Wakefields in New York, and not the Andersons in Seattle, right? How about getting all the families in Manhattan? Look at this polygon. Come on, I'm trying to reduce the font. There we go. Look at this polygon. So here where I'm saying I'm using st_intersects this time. St_intersects is a function that takes two GeoJSON properties. In this case, it's going to be a point. The first property is going to be a point where that family lives, and the second property is going to be a polygon that defines the shape of Manhattan. And if they intersect, then it'll be true. Of course, we expect at this time only one family, because we only have one family, the Wakefields, who actually live in Manhattan. Now you're asking, how did I get these coordinates? That's not really relevant, because there's any number of ways this information can be obtained, and it's really more about the spatial query, but I'll show you anyway. First of all, you should realize that there's a specific notation here. This is actually longitude, latitude. And different systems might have latitude, longitude, might inverse that, as well as inverting the order of the coordinates themselves in terms of whether you're defining a certain shape or of the world, or you're defining the entire world as the shape with that piece cut out, depending on the order of these things. So I use this little online tool where I could just click with the mouse, and it would feed me these coordinates. And this is for Google Maps. So where it's giving me latitudes and longitudes. So I had to massage the data a little bit and invert the longitudes and latitudes and reverse the vertex order, because otherwise I would be defining the shape of the entire world with Manhattan cut out, as opposed to Manhattan with the rest of the world cut out. But once I did that, I was able to get this query. I was able to get this demo running. Last one or two are just valid checking functions. So we'll just wrap up with those. You need to make sure that the GeoJSON, if you need to make sure that GeoJSON is valid, you call st is valid, you pass it in, and it'll tell you if it's valid. And in this case, it is valid. But if I reverse the latitude and longitudes, let's say because I copied from Google Maps and I forgot to invert them, st is valid is going to return false. And if I need to know the reason why, I need to know not just that it's not valid, but why it's not valid. I can call st is valid detailed, and it's going to tell me the reason, which is the latitude must be between -90 and 90. And wow, that's about a wrap for me. I mean, I think I covered almost everything. I didn't cover correlated subqueries, but I don't think there's much else that I missed.
Yeah, pretty pretty exhaustive, I think. Correlated subqueries,
yeah, they just speed things up for behind the scenes. Yeah, I should really throw them into the mix somewhere.
Yeah,
yeah.
I got some questions if you'd like.
Throw them at me.
Okay.
I'm gonna.
How will join queries be routed by the SDK without a partition key in the where clause?
What was the question? How will
join queries be routed by the SDK without a partition key in the
same,
where?
We're getting the same question over and over in different forms, right? Because a join is not affecting.
Doesn't matter.
Anything outside that document.
Is there?
It's not going to turn something single partition into something cross partition.
Anything? Yes, correct. Can you save RUs by selecting a few properties as opposed to select star?
Absolutely, 100%. You only want, if you don't need all. Well, you're going to save several things, but again, returning just a subset will reduce the computational cost of the query, which will reduce your RU charges, but they will also reduce overall bandwidth and latency because you're just returning less data.
Right.
It's just always better to limit it down.
The bigger the document, the bigger the savings, basically, as well.
Right.
Yep.
Right. And documents can be up to 2 megabytes. Right. Think about that. and you only need, let's say, 1 or 2 properties.
Dude,
So.
if your documents are 2 megabytes, I don't. You're going to have other issues.
Yeah.
Here's another one. What is the best way to check the existence of a criteria without fetching a document?
What is the best way?
I don't think you can. You got to fetch the document if you want to know.
I didn't get the question.
Yeah, I don't quite understand. Another question. This might be for me. Is the spatial viewer control likely to get added to Query Tool for Cosmos, just like it is in SS?
Good question, Mark.
I don't know of any effort to do that. At least not with Data Explorer.
You can check with that gentleman. I forget his name. He has quite a nice front end Visual Studio, SSMS style front end, web-based front end to Cosmos. Maybe he's the one to ask.
Who?
I can't remember his name. I'll have to ping you later.
All right. Yeah. Okay. So if you're still hanging out, folks, let us do our drawing. So anybody that asked a question here, you get to win awesome sticker, Cosmos DB sticker, and also equally awesome neoprene coaster. And I will lovingly mail these to you from my house. So let us, and to do that, if I draw your name, just DM me on Twitter and send me your name, your address, and your phone number. Sorry, Microsoft Mail needs phone numbers. I don't know why, to mail stuff, and I'll mail that stuff to you. All right, let's do a drawing here, shall we? David, you are our first winner. I'm going to pick 2. So go ahead and DM me on Twitter, your name, your address, and a phone number, and I will mail those off to you from my house. Okay, let's do another one.
Oh boy, I hope you can read those. Some of them. Okay.
Oh, Vernon. Okay, Vernon, you are our second winner. Just DM me on Twitter.
Congratulations.
I will. Yep, congratulations, folks. You get something awesome there. I think. Was there a question here? I think it was a comment. Right. Well, getting a comment on the question about selecting properties versus select star.
Right.
Certainly, the amount of documents you're querying.
Right. Yes, absolutely. Because that's why each time you return another page, you consume more RUs, right?
Sure. Yeah. So okay.
Well, so just because a query can return 1 million documents doesn't mean you have to retrieve all 1 million documents.
Right. And you can page through that as well, so that you're not.
You can use continuation tokens.
Yep.
You can,
yeah. If you're querying 1 million documents.
Or you can just drain the query, but then you will consume the maximum RUs.
Yep. That's a lot of RUs probably. So
yeah, but why are you returning so many documents?
Right. That's what I'm saying. Like if you're querying 1 million documents, then
I mean, if your scenario is key value store, nothing in this session really means anything. You just it's just point reads and writes, which are the most efficient operations. Anyway.
That is correct. If you are running key value store, then nothing you saw here over the last hour and 20 minutes is going to help. Might be interesting, but you're going to be using all of our CRUD SDK properties or methods. Well, Lenny, thank you so much.
Thank you, Mark.
Having you on, and
it's great being here.
Thank you.
Look forward to next time.
Joining us. Yeah, I haven't planned March yet.
All right.
I gotta go get the rest of us who were all said we were gonna do one of these to sign up. I got a couple more guys haven't done anything yet, so gotta get everybody signed up. So all righty. Thanks again.
Thank you.
Enjoy your week, and thank you everyone
Same
for
to you.
joining us. We will see
Thanks,
you
everyone.
again next month. I will get a new meetup scheduled here in the next week or two, and we'll run another one here sometime third week of March, hopefully.
Sounds good.
All right. Thank you, everyone.
Bye.
See you all next time. Bye-bye.